Welcome back to Jackson Square. Today we're looking at TEAC 711A that says I can model and solve one variable, two-step equations, and inequalities that represent problems. So we've learned how to solve one-step addition, one-step subtraction, one-step division, one-step multiplication. Now let's put all of those one steps together to be able to solve a two-step equation. So this time I'm going to go with old regular pencil and paper with our models. So our key is the same. We're going to draw a cup for each variable, and each cup represents 1x. We have an open circle or open square that's positive 1. We have a closed circle or closed square that's negative 1. So I'm going to start by looking at our problem. It says 2x minus 4 equals 6. So 2x minus 4 equals 6. We have 2x minus 4 on the left side and 6 on the right side. So I have 2x's, so I'm going to draw 2 cups, and I'm just going to draw little trapezoids to represent my cups. And then I have a minus 4. Remember, you take the number and the sign in front. So I'm going to draw squares, 4 of them, and shade them in to represent negative 4. And then on this side, I'm going to draw 6 squares to represent my positive 6. So when you're solving a two-step equation, you always want to get rid of the thing that's the easiest to get rid of. So when I'm looking at my cups and I'm looking at my counters, I know that x wants to be alone. These x's want to be left alone. They want to be isolated. Remember, the goal of the equation is to isolate and solve for the variable. So these want to be alone. What's on the side here? We have negative 4 counters, or negative 4. We want to get rid of the negative 4. That's the easiest thing. So the inverse of subtracting 4 is adding 4. So I'm going to add a positive 4 to this side. And remember, whatever I do to one side, I have to do to the other side to keep my equation balanced. So I'm going to add 4 here. Then as I go back, I notice that I have 0 pairs, okay? So I want to eliminate any 0 pairs. So a negative and a positive, that's a 0. A negative and a positive, that's a 0. That's a 0. That's a 0. So I got rid of those 4 0 pairs, and now I'm just left with 2x equal to, this is now 10, okay? So I have 10 of these counters, and I have 2 x's. Well, I just want to know what's the value of one of the x's, okay? So what am I going to do? I'm going to take those 10 counters and I'm going to divide them among the 2 cups. So 1 for you, 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 1 for you. So they're evenly divided among these 2 cups, and in each one I will end up with 5. Okay, so I have 10 being divided by 2, so x will equal 5. So 1 cup is going to be equal to 5. So let's write these steps numerically on the side. What would I do? 2x minus 4 equals 6. Remember, I'm going to draw my dotted line, make my 2 sides. I want to get rid of the negative 4 by adding 4 to both sides. These 4's cancel out. I bring down my 2x. I bring down my equal sign. 6 plus 4 is 10. Okay? To get x alone, just to find out what's the value of 1x, I have to do the opposite of multiplication, which is I'm going to divide both sides by 2. 2 divided by 2 is 1, so I will end up with 1x. Bring down that equal sign again, is equal to 10 divided by 2 is 5. Okay? That's our answer, x equals 5. I want to go ahead and show you how to check this answer. So the way you check this answer is called substitution. Just like when I'm absent and there's a teacher that takes my place, the sub, you're going to do the same thing. So anywhere we see x, we're going to put 5 in its place. So we're going to go back to the original problem, 2x minus 4 equals 6. Anywhere there's an x, I'm going to put 5 in its place. So 2 times 5 minus 4 equals 6. Hopefully you know that 2 times 5 is 10 minus 4. 10 minus 4 is 6 equals 6. Are those the same? Are they equal? Are they equivalent? Yes. So that's how you can check your answer by substituting in the 5 for x in the problem. We're able to check our answer. So let's jump on to another one. This time we have 3x plus 4 equals negative 8. So 3x, this time I'm going to use a large rectangle to represent my x's. And then we have plus 4, so that's going to be 4 open rectangles. And then we have negative 8. So shade those in. Okay. So again, x wants to be alone. We want to get x alone. We want to isolate and solve for the variable. We want to know what's the value of one of these rectangles. One of these. One of them represents what? So you always want to get rid of what's easiest. The easiest thing for me to get rid of is this positive 4, okay? Because these x's not so easy. They're being multiplied together, the 3 of them. So I'm going to get rid of the positive 4 by adding a negative 4 to both sides. And in this situation, the colors don't matter. It's more about the shaded and the open. I'm just using different colors to entertain myself. So I am going to eliminate all 0 pairs. So 0, 0, 0, 0. So now on this side, I'm left with 3x. And on this side, I have 9, 10, 11, 12, negative 12. So I'm going to have to take these negative 12 counters and split them or divide them into these 3 containers by going 1 for you, 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 for you, you. So when I do that, I end up with x equals negative 4. One of these x's is equal to a negative 4 if I split them up evenly among the x's. So let's write that down numerically. What would it look like? 3x plus 4 equals negative 8. Again, create my 2 sides. Okay? I only remember, you're only concerned with the side with x on it. I'm not concerned with the side of negative 8. This negative 8 will never move from this side. He will stay there. You're only concerned with what's on the side with x, okay? So everything that's going to be moved is going to come from this side. Nothing's going to be moving on that side. Everything's from here will be moving over, okay? So what's on the side with x? We have 3x and we have plus 4. So I can easily get rid of this 4 fast by doing the opposite of addition, which is subtraction, and subtracting 4 from both sides. So if I subtract 4 from both sides, what I end up with is positive 4 and a negative 4. Those zero out. I bring down my 3x. I bring down my equal sign, and then I have negative 8 and a negative 4. Again, if you need to think about your scoreboard, negatives would be on the same side. So anytime anything's on the same side, you add those together. 8, 9, 10, 11, 12. That would be 12 negative, okay? Don't forget all the things we've already learned. Everything that I've taught you, remember, it builds on top of each other. So we need all of this information that we've learned this year to be successful and help us solve these problems. So now we see 3x equals negative 12. Well, guess what? A 2-step equation is just 2 1-steps together. So in the first one, we got rid of the addition part. So now we just have a multiplication problem. So if you were good at solving 1-step multiplications, this is easy peasy, lemon squeezy. So I'm going to divide both sides by 3 to get the x alone. 3 divided by 3 is 1x. Bring down that equal sign again. And negative 12 divided by 3. 12 divided by 3 is 4. And then if you need to think about the sleeping mouse, if I have a positive and I have a negative, my answer is going to be negative. So this is going to be a -4, which we already knew because we modeled it first. But just in case, here it is for you. And again, if you wanted to go back and check your answer like we did previously, we could do that. So let's do that just to make sure. We're going to check. Our problem was 3x plus 4 equals -8. Anywhere I see an x, I'm going to put a -4 in. So 3 times -4 plus 4 equals 8. 3 times 4 is 12, and it's negative, so that's -12 plus 4 equals -8. And I know that 12 minus 4 is 8, and because 12 is larger, that's going to be a -8. So are these equal? Yes, they are equivalent. Okay, they are equivalent. Let's do one more model, and then we're going to do one more without a model. So here I have 4x minus 8 equals 8. We're going to start by drawing our 4 x's. I'm going to do rectangles again. Those are easy. I'm going to be modeling -8 on this side. This side is +8. So to get rid of, again, we only want to get the x alone. So I have this -8. To get rid of a -8, I need to add +8. The opposite of subtraction is addition, the inverse operation. So I'm going to add +8 to this side. And remember, equations are all about balance, keeping those two sides balanced. So if I have a -8 on this side, if I added a +8 on this side, I also have to add a +8 on this side to keep the balance. Okay, so on this side, I see I have 0 pairs. I'm going to go through and eliminate those 0 pairs. And once I eliminate the 0 pairs on that side, I'm only left with the 4 x's, and I'm left with, now I think that's 16 squares on the other side. So I have to take those 16 squares and evenly divide them among each one of these 4 cups or 4 x's. And if I say one for you, one for you, one for you, one for you, and I evenly divide them, I will see that each one of these is going to be equal to 4. They will evenly divide into 4 groups with 4 in each group. So the value of x equals +4. That's the model. Love the models. And here we go. If we do it numerically, we solve the problem with the algorithm. As some of you guys like to say, I'm using the algorithm. If you follow the logical steps of how to solve the problem, that's the algorithm. So the first thing we did was add 8 to both sides. These 8s cancel out, bring down my 4x, bring down my equal sign. This is 16. So now this 2-step has easily and quickly become a 1-step. Please make sure you're paying attention. A lot of times kids can do the first step, then when they get to the second step, they're lost. It's just another 1-step, okay? So I am going to solve this problem. I'm going to do the opposite of multiplication, which is division. I'm going to divide both sides by 4. Okay, so 4x, 4 divided by 4 is 1x. Bring down that equal sign again. 16 divided by 4 is 4. So the value of x equals 4, again, which is the same as our model. And we could go in and check it. You are more than welcome to check it to verify, but I can do it in my head. I know that 4 times 4 is 16, and 16 minus 8 will give me 8. As you can see, all of these problems have multiplication and addition or subtraction, and we'll do some division problems tomorrow. Today, I just want to start with the multiplication before we get into multiplying both sides by the reciprocal. That gets a little bit more complex. So I'm going to solve one more problem for you guys. And this problem is not going to have a model. We're just going to do the numeric part of it. The problem is 45 equals negative 27 minus 9x. So I want to do something different that looked a little bit different with a little bit more negatives in it, just so you guys have some ideas of what this will look like if you're encountered with one. So again, this time x is on the right side. Does that matter? It doesn't matter what side that the x is on. It's totally insignificant, the side. So we're going to just solve this problem as normal. Remember, x wants to be alone. What's on this side with x? There's a negative 27, and we have a negative 9x this time, which is a little bit different than what we typically are used to doing. And I could model this problem. I just don't want to draw out 45 counters or 27 or negative 9x's. So I'm just going to solve it. So the first thing I'm going to do is get rid of the negative 27. The opposite of a negative 27, or the inverse of subtracting 27, is adding 27. I'm going to add 27 to both sides, keeping the balance. A positive and a negative, that will cancel out. I'm going to bring down my negative 9x. Please do not leave that negative up there. It comes down to. Bring down my equal sign, and then here I'm bringing this down. This is 12, here my 1, 4, 5, 6, 7, 72. So then this is a one-step multiplication problem. What do I need to do to both sides to get x alone? I need to divide both sides, but this time I'm not dividing by a positive. I'm dividing by a negative 9. So please make sure when you divide, you're dividing by that negative 9. You don't want to leave that negative up there and end up with a negative x, which is not hard to get rid of, but why do extra work? Okay, so make sure you're dividing both sides by negative 9. Negative 9 divided by negative 9 is going to give me a positive 1x. I'm left with x. 72 divided by 9 will give me a negative 8. Again, remember your sleepy mouse. If I have a negative and a positive, my answer is going to be negative. Cover those up. My answer will be a negative 8. Okay? And you could go through and check this. I could see that if I have negative and a negative 9, that will give me a positive 72. And then a positive 72 minus 27 will give me a positive 45. So that is correct. So I hope that this has been helpful. I hope you are up and ready for the challenge of solving two-step equations. I think that solving two-step equations are so much fun and so exciting. So let's go practice. Good luck.